Hello and welcome to day 5 of our Graph Beginner to Mastery series. So today is day 5 and our question today is LeetCode 2812, which is find the safest path in the grid. So I think it is marked medium on LeetCode, but I think it is an upper medium or towards harder side. It is not an average medium question. It requires like a depth concept of the graphs, including Dijkstra. Dijkstra you need to know in depth, which I will which I will help make you practice properly. And obviously BFS, DFS, these are prerequisites. So our series, start with introduction. Our series basically takes you from the beginner level. You need to be at the beginner level, means you need to know basic BFS, DFS or Dijkstra or DSU. You just need to know the basics, which driver or any average sheet will take you to. And from there, we will take you to mastery using our mastery sheet. And today is day 5. Currently, the graph mastery playlist is going on. So question is 2812. I hope that you have attempted or seen the question for 10 minutes at least. I'm assuming that you know the question statement because directly seeing the solution to a question is redundant. It doesn't make your skills better. So okay, still let me give an introduction to problem. You are given a matrix of filled with ones and zeros. You need to find a path from the first 0, 0 to the last index, that is n minus 1, n minus 1. And whatever path you take, you need to take the one with the farthest distance from any one. Like let's take an example. Let's say path is 0, 0, 0, 0, 0, 0, 0, 0, 1. Let's consider two paths. So first path is this. This is the path 1, and the second path is this is path 2. Okay, let me just make it in a better way. So let's say second path is this. Okay, so second path is this and first path is this. So the according to question, if you have read it properly, you will understand that the answer to this path would be 2, because our closest 0 to 1 has a distance of 2 from it, which is this 0 or this 0. It has a distance of 2 from it. But in case of this path, the answer to according to the question would be 1, because the closest 0 to 1 in this path has a distance of 1. That's why hence you will have a distance of 1 in this case. So obviously our ideal answer would be this path, which is we need to select the farthest minimum distance from 1, which is 2 in this case. So this is the introduction to problem. So intuition is obviously basic. It is supposed to be a 4-directional movement, and a matrix is given. You need to find the shortest or minimum path. So all these things point out to one and only obvious solution, which is Dijkstra. So Dijkstra is a prerequisite to this question. You are supposed to know Dijkstra's algorithm. Then I will teach you this question, and I'm sure you will scale up by the end of this video. So let's go with the dry run. Let's start with the brute force firstly. Let me take a good example. Let's say we are given a matrix and which is 0, 0, 1, 0, 1, 0, 0, 0, 0. So we are supposed to go from this path to here. So the view of path in my mind is this, or say this. So I want the brute force is that we will check all the 4 valid directions. These are invalid, so we will consider it. We will check in all the 4 valid direction and check if the current minimum distance gets updated. Like here the minimum distance is 2. We are given Manhattan distance. So here it is 2. Manhattan distance is basically the modulo addition of both the x and y coordinate between two index. So here the Manhattan distance is 2, and since we go here our Manhattan distance becomes 1. So the new safeness factor becomes 1. So ideally what our approach was to, whenever we visit a new cell 4 directionally, we would apply DFS and check for the closest one and update the maximum factor likewise. But this is a name approach. We won't get to the answer like this, since going to the going to the next node and again applying BFS, so this would hit TLE and it won't even get accepted to at this question in LeetCode, let alone the interview. So it would hit TLE in LeetCode. So ideally what we are supposed to do is we are moving towards step 3, that is a trial. So ideally what we are supposed to do is pre-compute an array, pre-compute an n cross n array, which will tell what this array would tell. This array would tell the minimum distance of each index, from closest one. So basically we have pre-computed all the things which we were doing by applying DFS at each cell. Instead of doing DFS at each cell, we can directly access it from this array. Minimum distance of each cell from nearest one. So this way we have got, and this can be done using DFS. This is a basic. Using DFS or BFS, we will make this array. Let's call this array closest thief array. Or in my code, I have used the name distance. So let's call it distance array. Although this is, you should not be confused using like the distance array we use in Dijkstra. The distance array used in Dijkstra, I've called it answer distance in the question. This is the Dijkstra's distance array, and the pre-computed array is named distance in the code, which I will explain later. So currently we are supposed to calculate this distance array, which will give us the minimum distance of each one. Then we will start, when we're using priority queue from Dijkstra, we will start calculating, uh, we will firstly push the 0, 0 index in the priority queue and along with the distance, closest distance from 1. Then we will move 4 directionally, which is again a prerequisite of Dijkstra. I hope you know it. So it move 4 directionally and check uh, if distance needs to be updated. Like let's say in this case, x assume values here suitably. Let's say here the minimum distance from 1 was 2, which we got from the distance array. And if we move here, the minimum distance from, like, let's take a real example. Let's say it is 0, 0, 1, 1, no, 0, 1, 0, 0, 0, 0. So our corresponding distance array would look like this. For this grid given in question, our corresponding distance array should look like 2, 1, 0, 3, 1, 2, 1, and 0, 1, 2. So how we got this? We, for this 0, our closest one is 2 Manhattan distance away. So here we have 2. For this 0, our closest one is 1 Manhattan distance away. So our closest one is 1. For 1, obviously it's 0. And similarly for all the values, like for this 0, we have the minimum 1, 2 Manhattan distance away. So here we have 2. So this way we have calculated the distance array. This can be done using BFS. What we will do is we will start with all the ones, we'll push all the ones in queue along with the current distance. So current distance is 0 and we will push the ones index of the ones there. So that is 0, 2, and our queue will also have current distance is 0, and for this one it will have 2, 0. Then we would move 4 directionally and update the current distance. So this would have 1 here, like this would have 1, and similarly 4 directionally here this would have 1. Increase the current distance by 1, and then again move 4 directionally. So this would have 2 and this would have 2. So this can be calculated. This is a prerequisite of DFS BFS. Okay, so once you have done this, then we will move to the main core algorithm, which is Dijkstra. So the priority queue will currently have the current safeness factor of 0, 0, which is 2, 2. Then we'll check 4 directionally, and we will push both inside the queue, and we will check if the current distance of this is less than the current distance of this one. Like let's say the current distance of this is 2, but current distance of this is 1, corresponding to this array, this is 1. So now the current distance of this path becomes 1. Similarly, for this path, the current distance becomes 1. Why so? Because we are supposed to take the minimum distance from nearest one. So for this path, the minimum distance is obviously 1. So that's why the path gets updated and we keep on updating the minimum distance. And in priority queue, we would store what would be that at the top of priority queue, it would be the one with the maximum safeness factor. So that means the priority queue, at the top it will contain the cell with the maximum safeness factor. So whichever path's current value is the maximum, so it will select that. So let's do a try run. Currently both have 1, 1 here. So anything will be selected. Let's say this is selected. Again, we move 4 directionally, update the new minimum distance, and we would correspondingly update the priority queue. And yeah, this is again a extra prerequisite. We will store an answer distance array, which should again be n cross n. Initialize everything. Yeah, this is where the classic Dijkstra doesn't work here. We need to initialize everything with 0 here because we are looking for maximum safeness factor. In normal Dijkstra, what we generally do is we find the shortest path or shortest time, so we initialize everything with int max. But here we are supposed to initialize everything with maximum distance. So we initialize everything with 0, update the 0th value, check 4 directionally. If a better value is found, we would update the value. Like if a greater value than current value is found, we will update the value and push inside the priority queue. And finally, after all the iterations, we will return the end index of the array. So let's do a quick try run on a small example to help you understand this better. Suppose we only take one of the one, and the path is 0, 0, 0, and 0, 0. Okay, so this works. So what would happen? We would get firstly compute the pre-computed array of distance, and that would be 1, 2, 3. Now don't ask me how is that calculated. I already told BFS, DFS would help us calculate this distance array. So it would be 1, 2, 3, 0, 1, 2. Okay, this is the distance array. Now our answer distance array, which would be used in the priority queue, that is currently all initialized to 0. These are three different arrays. So currently everything's initialized to 0, and we have a priority queue here, and we have a priority queue here. And so currently we will push 0, 0 inside the priority queue, and the current distance will be stored. So priority queue will contain 1, the x index and the y index. Okay, and this would be updated to 1. Since a better value is found, 1 is better than this, so then the top element will be popped out. So the current distance is 1, like current safeness factor is 1, x index is 1 and y index is 1. Using 4 directional movements, we would check for this value and this value. So this value would give us a safeness factor of 0, and 0 is already, like, it is not an upgrade. 0 is already the minimum value inside the answer distance array, so we won't even push this inside the priority queue. Now for this one, we would go here and we would calculate the new safeness factor. So new safeness factor is, as I mentioned, it would be minimum of current safeness factor, which is 1, or the new safeness factor. So what is the new safeness factor? It is 2. 2. So the new safeness factor would again come out to be 1, which is true because for this path, the new safeness factor, for this path, the safeness factor is 1 because the closest one is only 1 distance away. Yeah, so this path has 1 safeness factor. Now the answer distance array will get updated since 1 is an upgrade from 0. So this would get changed to 1 and it would be pushed inside priority queue with the current minimum distance as 1. And the x and y index would be updated. Then again we would check 4 directionally. So like we will check here and here, this way. So the new distance array would again, here we would get the new safeness factor as 1, and here we would get the new safeness factor as 3. Again, the new safeness factor would be minimum of 1, 3 in this case because the safeness factor of this was 1. Okay, like current safeness factor was 1 because we are pushing it from priority queue, not from this index. And the new safeness factor is pushed from here. So minimum of 1, 3 would give us 1 and minimum of 1, 2 would also give us 1. But since it is an upgrade from 0, so this would get updated to 1, this would get updated to 1, and both of them will be pushed to priority queue. So 0, 2 is pushed and 1, 1 is pushed. Okay, then we would finally check, again move 4 directionally, check the new safeness factor, which would be minimum of 1, 2 and minimum of 1, 2 from both the directions, which would give us 1, and ultimately this value gets updated to 1 and priority queue will get empty ultimately. Hence we would return the final value, which would be 1, which is also correct, as you can see for any path involving this array. This path or this path, both are ideal answer, as the minimum distance from 1 is 1 and this is maximized. Like we can't get a minimum distance of 2 from 1 in any of these paths going from here to here. So yeah, so answer return 1, which is correct. Let's quickly go towards the code to help me make you understand the code. Okay, so firstly we would make a valid function. Okay, so firstly we would make the valid function and it would return false if the index is out of bounds. This is a like define function. It is very necessary. Let me just make the code. Okay, so it is very necessary because it helps us save our effort. We can simply use ds instead of writing all of this. And this pre-compute function calculates the distance array, as I mentioned. Distance array is calculated using DFS, normal DFS. Firstly, all the ones are pushed inside the queue with the distance array marked as 0. So all the ones are pushed inside the queue, and while the queue is not empty, we update the current distance level. And as far as as long as we find a 0, we update the current value to CL plus 1, and we continue traversing. As I mentioned, this is a prerequisite. This is normal BFS DFS. Now this is where a complex part comes in. We need to define the priority of priority queue because we cannot use a normal greater int this time. We need to store the maximum safeness factor at top, as also I saw on Dryden, as I shown you on Dryden. We need to have the maximum safeness factor on top of the queue. So this is how you define a custom function, custom comparator. This custom comparator will help us define the priority, like whichever is smaller one go deep inside the queue and one with a larger value will come at the top of the queue. And just take a note of the syntax. This is how you define, this is how you change the priority of a normal priority queue using Decla type and function. Custom is the name of custom comparator. Then for the maximum safeness factor, we use two distance array like four directional movement. We always use this array. You should know this thing. Then we calculate a distance array which send it to pre-compute to get the minimum distance. And then using priority queue and Dijkstra, this is the answer distance array used for Dijkstra algorithm. And for Dijkstra, we start with answer distance of 0, 0 is 0. Okay, wait, there's a bug here. We need to initialize it with distance 0, 0. So what my mistake was, I always initialized this with 0. Always the distance array, answer distance array was initialized with 0, but we need to initialize this with 1 because that is the minimum safest factor. Then push inside the queue the current distance value, get the current safety value, get the x and y index, and pop it from the queue. Then traverse the 4 directional vector, get the new x and y, and if it is not valid, then continue. If it's valid, then we get the new safety factor, which as I mentioned, it is minimum of current safety factor got from the priority queue, or the new minimum, which is got from the distance array, which we pre-computed. So whichever is minimum, that is our new safety. And if the new safety is a safer option than current like if it is a more safeness factor it has, then the current value stored in answer distant. This is also priority queue like the extra part. So if it is more safe than the current distance stored in the answer distance array, then we would update the answer distance array with the new safety because it is a better option, and push inside the priority queue to check for new possibilities. And finally, we turn the last index of the whole of the grid. But I know it will hit TLE at one final case, and I'm trying to teach you all something more deep. Let's say, okay, so it got accepted, but what I was trying to teach is we got X and Y here only, like then we don't need to further move forward. Like if we've already reached the last index, then we simply return the answer distance of x minus 1 x comma y, because this would mean that once an index has been popped from priority queue, then that means that it won't be updated anytime soon. So yeah, this was the whole code. Let's discuss the time complexity. So time complexity of this code is, we applied Dijkstra, that would be e log v. We applied custom sorting, that would be n log n. So the custom sorting, the priority queue would be n log k. So it would be somewhere around n log k only, n log n only. And the vertex, let me see. It would be n square log n because n is the grid length, and we also traverse the grid columns, so it would be n square log n. And the space complexity would be n square because we used answer distance array and everything like that.